Hi everyone, today we're going to be talking about analysis of variance, so it's also known as ANOVA, and linear regressions, so that's simple and multiple linear regressions. Let's start off with ANOVA. It's basically where we use a categorical variable to predict a continuous variable. So it's going to check if there are statistically significant differences between between 3 or more groups. Okay, so let's say there's 2 different groups, right? Like I'm just gonna randomly do something. These are the 2 groups, and remember that when we want to check out, the differences between 2 different groups, we can use t-tests. But now that we have this third different group, we are going to check the significant differences between them using our ANOVA. Okay, so suppose I'm interested in seeing if there is a difference in age between people who use, okay, let me just write this out, people who use Google Pixel, okay, people who use an iPhone, that's Apple, and people who use like a Huawei, okay? So, and we want to see if, here we have 3 ages, right? We want to see if there's any difference in the age group of these people. So now I have to come up with a research question. So my research question is going to be, is there a difference, right? Is there a difference in population between the groups of the independent variable with respect to the dependent variable? Great. So now we have our research question. And note here we are talking about population, right? And so keep in mind that, we're not going to be able to get a population, obviously. We're not going to be able to get every single user that has these phones. So we have to make sure that our sample is as diverse and unbiased as possible. Okay, so now let's define the variables. We have our independent variable, right, which is the phone model. So, yeah, so basically these 3 right here, right? And we have our dependent variable, which is going to be the age of the users. So the dependent variable is going to be the age of the users. So we're trying to see if, again, the phone model has any influence on age. Now we have to have our hypothesis. So we will have our null hypothesis. And this is going to say that there is no difference in population between the means of the groups. And then we're going to have our alternative hypothesis, right? Okay. This is represented as H1. And this is going to say the opposite, right? So that there is a difference between at least two means of the groups. Okay. So now let's talk a little bit about what regression analysis is. So it basically predicts one variable based on another variable, right? So it's also used to measure the influence of one variable on another, which is basically the same thing. So for instance, what predicts someone's mortgage rate? So here we have a house, mortgage rate, right? Well, some of the factors can be like income, right? Another factor can be, like previous assets. Another factor can be, like debts or loans, right? So this variable, mortgage rate, is called, so I'm going to write here, mortgage rate is called our dependent variable criterion. And these other variables that we were using to predict this mortgage rate are called predictors, or independent variables. Okay, cool. So we have two different types of linear regressions, right? We have the simple linear regression, and this basically uses one independent variable to predict the dependent variable. And the key here is the 1. Okay. So for instance, let's say that the relationship in, let's show how it can be represented visually, right? So here we will have some data points, and this is a scatter plot, which is how we usually visually represent linear regressions. The stronger the linear relationship is, the more closely together these data points will be, and may even form a straight line. So the equation for this model is going to be y hat is equal to b times x plus a, where b is going to be our slope, x is going to be our independent variable, and our, this is not looking too much like an a, plus a. And our a is going to be the y-intercept, right? So is the intercept with the x-axis. So right here. Okay. So what about the multiple? What about the multiple? Regression. This basically uses multiple independent, so uses multiple independent variables to predict our dependent variable. All right, so we have several independent variables here. And so the equation is, of course, going to look different. And the equation here is y hat is equal to something like b1 multiplied by x1 plus, b2 multiplied by x2 plus, let's say, bn multiplied by xn plus a. Yeah, okay. So to give you an example, right, using what we already talked about, so for a simple linear regression, we would have, right now, what I'm talking about is this, right? We would have the mortgage rate, but we would only use one predictor. So for example, we would only use income. And for the multiple linear regression, we could use all of these predictors. Okay, now let's talk about, all right, I get what's going on, but how do I interpret the results? Okay, so you may have seen something like this R, right? And this is called the multiple correlation coefficient. So correlation okay, and this measures the relationship between the dependent and independent variables. So usually, oops, sorry about that. So usually, where are we at? Yeah. This value will be between -1 to 1. Okay? And it can also be, so for example, if it is, -1, that means it is strong and negative. If it's 1, then it's strong and positive. And keep in mind, I said between, so it's not exactly going to have to be -1 or 1. It can be, 0.9, 0.8, whatever. And it can also be 0. And if it's 0, then you guessed it, there is a no or like poor relation. Okay. Now there's two more things I want to quickly talk about. One of them is R squared. And R squared basically tells us how much variance of the dependent variable can be explained by the independent variable. And another evaluation that you can make, another factor, is the standard estimation error. And this tells us how much overestimation has been done to the dependent variable. So yeah, that's pretty much our basic intro to regressions and variance. analysis of variance. If you have any sort of questions, please leave them down in the comments, and I'll get back to you as soon as I can. And yeah, thank you so much for making it.